In this lab, we determined the coefficient of kinetic and static friction.
A wooden block and an aluminum block were pushed down a wooden incline 10 different times to find the angle at which it begins sliding down. To minimize uncertainty, we made sure the wooden incline was moved slowly with no jerking motions. We derived a formula for the coefficient of static friction through a free body diagram of a block going down an incline that had normal force, weight force, and static friction force acting upon it.
And then we used Newton's second law to find the force, net force on the x-axis and the y-axis. And after doing all the calculations, we found that coefficient of static force is equal to tan theta.
And then we did the same steps to derive the equation for the coefficient of the kinetic friction force.
For this problem, the critical angle for the wood and the aluminum were calculated by averaging all the angles from each trial, and the uncertainty for the angle was converted to radians. The coefficient of the static friction was found by using the previous equation, which is mu s equals tan theta. The coefficient of static friction for the wood is 0.58, and for the aluminum, it is 0.44.
For the uncertainty of the coefficient of static friction, we use the formula sigma theta of the critical angle, SEC squared, times theta of the critical angle. This formula was given to us, and we plugged in our values and got 0.035 for the wood's mu s uncertainty and 0.019 for the aluminum mu s uncertainty.
The video was then put into Tracker, where we can see the wood and the aluminum slide down frame by frame.
The data from Tracker was then copied and pasted into a spreadsheet where it created two charts for wood and aluminum with a polynomial fit type, which is also the same fit type that was used when measuring G in the previous lab. An equation at the top of each chart was also provided to find the acceleration of the wood and the aluminum. We also determined that our uncertainty of x was 0.005. And when we plugged in that uncertainty into the spreadsheet, it gave us the uncertainty for acceleration. The acceleration of the wood was determined as 1.80, and the sigma acceleration of the wood was 0.00029. The acceleration of the aluminum was 1.87, and the sigma acceleration of the aluminum was 0.00007. Next, we calculated and determined the coefficients of kinetic friction. The formula tan theta minus A over G SEC theta was used to find the kinetic friction. For the wood, the coefficient of kinetic friction was 0.36. And for the uncertainty of the coefficient of kinetic friction, we used this equation that was given to us and determined that sigma mu k to be 0.06. The same equations were used to find the coefficient of kinetic friction and the sigma mu k. The coefficient of kinetic friction was determined to be 0.23, and then for the uncertainty of the coefficient of kinetic friction, we also used the same equation, and we determined that the sigma mu k was 0.03. These are the values of static friction and the kinetic friction that were determined for the wooden block and the aluminum block. We concluded that the uncertainties were low and the measurements were relevant.